Here in this section we have Taylor and Maclaurin series definition. Let f be a function with derivatives of all orders throughout some interval containing a as an interior point. Then the Taylor series generated by f at x equal to a is sum of k derivative divided by k factorial. So here we have this function f, and here is k derivative, and k is from 0 to infinite. So this will multiply by x minus a to the k power. This is equal to f of a plus first derivative of a multiplied by x minus a plus second derivative of a divided by 2 factorial times x minus a to the second power plus 3 dots plus n derivative f divided by n factorial multiplied by x minus a to the n power plus, this goes to infinite, so using 3 dots. And what we have for Maclaurin series of f is the Taylor series generated by f at x equal to 0. So on top we had x equal to a, now here on this part we have x 0, or what we have here, sum of k derivative here instead of a that we had on top, we have 0 divided by k factorial multiplied by x to the k power. K is from 0 to infinite, so this is equal to f of 0 plus first derivative. Here we have 0 times x plus second derivative divided by 2 factorial. Here again we have 0, and then multiply by x to the second power plus 3 dots plus and derivative divided by n factorial. Here again 0 multiplied by x to the n power plus goes to infinity, so use 3 dots. Now here in this part we have the definition. Let f be a function with derivatives of order k for k from 1 up to n, so uppercase n, in some interval containing a as an interior point. Then for any integer n from 0 through uppercase n, the Taylor polynomial of order n generated by f at x equal to a is the polynomial piece of n equal to f of a plus first derivative of a multiplied by x minus a plus second derivative divided by 2 factorial multiplied by x minus a to the second power plus 3 dots plus k derivative divided by k factorial multiplied by x minus a to the k power plus here again 3 dots plus n derivative divided by n factorial multiplied by x minus a to the n power. Example, find the Taylor polynomial of orders 0, 1, 2, and 3 generated by f at a. F of x is equal to sine, and a is pi over 6. So first, I'll find the Taylor polynomial of order 0. So we have f of a equal to sine a is pi over 6, and sine pi over 6 is equal to 1 over 2. So this means p sub 0 is equal to 1 over 2. And now finding Taylor polynomial of order 1. Now that we have p1, so that is equal to f of a plus first derivative of a times x minus a. So what we have for f of x is equal to sine x, finding first derivative of f, that is equal to cosine x. Now find first derivative of x when x is equal to a. So f prime a, that is equal to, using this part, cosine instead of x we have pi over 6, because of what is given, a is pi over 6, and cosine pi over 6 is equal to square root of 3 over 2. So what we have for p sub 1, that is equal to f of a from part a, this is equal to 1 over 2, and then add what we have for first derivative from this part, it's square root of 3 over 2, and then multiply by x minus a is pi over 6. Now finding Taylor polynomial of order 2. So first step here, finding second derivative. So first derivative was equal to cosine, so second derivative is equal to negative sine x, and then finding second derivative in x is a. So this is equal to negative sine pi over 6, and that is equal to negative 1 over 2. So now based on what we have here for p sub 2, this is equal to f of a is equal to 1 over 2 from first part, and then add first derivative was equal to square root of 3 over 2, multiply x minus a is pi over 6, plus here we have 2 factorial, so 1 over 2 factorial multiplied by what we have for second derivative from this part is negative 1 over 2 multiplied by x minus a is pi over 6, and then power is 2. So I multiply this part, 2 factorial is equal to 2, so we have 1 over 2 times negative 1 over 2, that is equal to negative 1 over 4. So p sub 2 is equal to 1 over 2 plus square root of 3 divided by 2 times x minus pi over 6 minus 1 over 4 times x minus pi over 6 to the second power. Now find the Taylor polynomial of order 3, which is in this form. So we have first derivative, we have second derivative, and we should find third derivative. So second derivative was equal to negative sine x. Based on that, finding third derivative. This is equal to negative cosine x. And then find third derivative when x is equal to a. So negative cosine a is pi over 6. And this is equal to negative square root of 3 over 2. So Taylor polynomial of order 3, this is equal to what we have for f of a is 1 over 2 plus first derivative is square root of 3 over 2 times x minus a is pi over 6 plus 1 over 2 factorial multiplied by negative 1 over 2 multiplied by x minus pi over 6 to the second power. Now we should add what we had from this part, third derivative. So add 1 over 3 factorial times negative square root of 3 over 2 multiplied by x minus a is pi over 6 to the third power. So simplify, this is equal to 1 over 2 plus square root of 3 over 2 times x minus pi over 6. Then this part we have 2 factorial is 2, so we have 1 over 2 times negative 1 over 2, so this is negative 1 over 4 times x minus pi over 6 to the second power. Now here we have 3 factorial, so 3 factorial is 3 times 2, so that is 6. So we have 1 over 6 times negative square root of 3 over 2. So we have negative square root of 3 divided by 6 times 2, so that is 12 in denominator. Again, 3 factorial is 3 times 2, and that is 6. So 6 times 2, it is 12 here in denominator. Find the Maclaurin series of the function f of x is equal to a times cosine 6 pi x, and then multiply by x minus pi over 6 to the third power. So first, find few derivatives of f of x. So first derivative is equal to, here we have 6 times a, so that is 48. Here we have pi, so 48 pi times, here we have cosine, so it's negative sine. So that means we have negative 48 pi sine 6 pi x, and for second derivative, we have 6 times negative 48, so that is negative 288. And here again we have pi, so pi times pi is pi squared. Then we have sine, so second derivative. Here we have cosine 6 pi x. So this is equal to negative 288 pi squared times cosine 6 pi x. Now third derivative based on what we have here on this part. We have 6 pi times what we have on this part, that is 1728 pi cubed multiplied by sine 6 pi x. So based on what we have here, note that the even numbered derivatives all contain cosine. So here we have even derivative and here we have cosine. And odd number derivatives all contain sine. So here we have odd derivatives and we have sine. So we want to find the pattern. So we're gonna work based on even and odd derivatives. So find two separate formulas, one for even derivatives and one for odd derivatives. So in this case, I used 2 times n for even and 2 times n plus 1 for odd. I added 4th derivative here on this part. So that is equal to 10,368 pi to the 4th power times cosine 6 pi x. So here on this part, I listed what we had for even number derivatives. So f of x is 8 cosine 6 pi x. Second derivative is negative 288 pi squared cosine 6 pi x. And fourth derivative is 10,368 pi to the 4th power cosine 6 pi x. And based on what we have here on this part, finding coefficients. So coefficient is, for the first one is 8. For second derivative, coefficient is what we have here on this part. And based on what we have here, 8, I'm using 8 here again. And that is, so 8 times 36. So 8 times 36 is equal to 288. And then here we have 10,368 pi to the 4th power. So that is 8 times 1,296 pi to the 4th power. So this 8 times 1,296 is equal to 10,368. And then, so here, first we have positive, then here we have negative, again we have positive, so that means we have negative 1 to the nth power. So negative 1 to the nth power, if n equal to 0, that is equal to 1, so that is what we have here on this part. Negative 1 when n is equal to 1. Here we have negative 1, which is here on this part, and then n is 2, so negative 1 to the 2nd power, that is positive 1, and here we have positive. So we're going to use negative 1 to the nth power, and then multiply by what we had here on this part, we used 8. So 8 multiplied by, here we have 36, that is 6 squared. So we have 6 power 2 times n. So n on this part is equal to 1. So we're going to have 6 squared for that part. And then for this part, n is 2. So we have 6 to the 4th power multiplied by 8. So 8 times 6 to the 4th power is equal to 8 times 1,296. So this is what our pattern is for even number derivatives. And then I multiply by pi power 2 times n, and then multiply by cosine 6 pi x. Now finding pattern for odd derivatives. Here we have first derivative, third derivative, and we have fifth derivative. So based on what we have here on this board, this is equal to negative 1. So again, I use negative 1, but here in this case, power is n plus 1 instead of n. So for even derivative, we used same pattern. We have 8 multiplied by 6, but here 6 for this part, power instead of 2 times n is 2 times n plus 1. And for pi, instead of 2n, power is 2n plus 1. And then multiply by sine 6 by x. Now finding even derivative for when x is 0. So this is equal to -1 power n times 8 times 6 power 2n multiply pi power 2n multiply cosine. So here for even derivative we had cosine. So having x equal to 0, we're going to have cosine 0. So cosine 0 is equal to 1. So what we have for even derivative when x is 0, this is equal to -1 to the n power multiplied by 8 times 6 power is 2n multiplied by pi power is 2n. And what we have for odd derivative when x is 0, this is equal to -1 power n plus 1 times 8 times 6 power 2n plus 1 times pi power 2n plus 1. And here we have sine. So having x equal to 0, we're going to have sine 0. And sine 0 is 0. Because of that, odd derivative when x is equal to 0 is equal to 0. So for this part, we have 0. Since -288 pi squared cosine 6 pi x for all n, only even powers of x occur in the Maclaurin series for f of x equal to 8 cosine 6 pi x. So this one was second derivative. Complete the first two non-zero terms by evaluating even derivatives when x is 0 for n equal to 1 to obtain second derivative. Here we have 0. This is equal to -288 pi squared, because having x equal to 0, we're going to have cosine 0, and that is equal to 1. And then dividing by 2 factorial gives the coefficient for the x squared term. So what we have here for Maclaurin, we have f of 0 plus first derivative times x plus second derivative times x squared divided by 2 factorial plus third derivative multiplied by x cubed divided by 3 factorial plus 3 dots plus n derivative multiplied by x to the n power divided by n factorial plus 3 dots, because this goes to infinite. And this is equal to, so f of 0 is equal to 8. So using 0 here on this part, meaning that we're going to have cosine 0. Cosine 0 is 1. 1 times 8, we have 8. Plus first derivative of 0. For first derivative, we have sine, and sine 0 is 0. That's why we have 0 for odd derivatives. So for odd derivatives, here we have 0 for all of these. And then multiply by x. So adding what we have for second derivative is -288 pi squared times x squared divided by 2 factorial. So how I explained here as this one, it's -288 pi squared. And then divide by 2 factorial, but we have x squared on that part. And rewriting this part, now simplify. So this is equal to 8 plus 0 times x plus, so 2 factorial is 2. What we have here is -288 divided by 2, that is -144. So we have -144 times pi squared times x squared plus, so rewriting this part and rewriting this part. Finally, write the Maclaurin series for f in summation notation. Only the non-zero terms are shown in the expansion below. So find the Maclaurin series of the function by substituting this part for the general term, which is in this form. So we're going to have 8 minus, so this part is 0, this part is 0. We're going to have 8 minus 144 times pi squared times x squared plus 3 dots plus even derivative multiplied by x power 2 times n divided by 2 times n factorial plus 3 dots. So this is equal to sum of, we have this part here. So -1 to the n power multiplied by 8 multiplied by 6 power is 2 times n multiplied by pi power is 2 times n, then multiplied by what we have here on this part is x power 2n divided by what we have here is 2n factorial.